The Galois counter mode GCM is a block cipher mode of operation and an instance of authenticated encryption with associated data. As such, GCM provides both confidentiality as well as authenticity to data and additionally can bind the ciphertext to associated data such that the ciphertext is only authenticated in context of the same associated data. The verification of the authenticity of a ciphertext fails if either the key used was wrong, or the initialization vector, or the authentication tag, or the ciphertext, or the associated data was wrong. How to use GCM with AES in Python will be shown in the following demonstration. The steps required to demo the use of GCM with AES is to have a symmetric key used for AES, to have an initialization vector for GCM, to have a plaintext to encrypt and authenticate, to have associated data against which the authenticity should be coupled, to then encrypt and authenticate the plaintext, and to then finally verify the authenticity of the received ciphertext and to decrypt the ciphertext back to the plaintext. For the key, I opted for a randomly sampled 256-bit key. For the initialization vector, an IV of length 96 bits is recommended to be used with GCM, which I randomly sampled as well. The plaintext is a simple byte string with the name of this course. The associated data is just some byte string as well, reading context of using AES-GCM. For the encryption with GCM, no padding is required, and an AES-GCM encryptor can be created with the cryptography library by providing the key and the IV. This encryptor is then provided with the associated data and can then calculate the ciphertext and the authentication tag. Having all of this, the ciphertext can then be verified for authenticity and decrypted by creating an AES-GCM decryptor with the cryptography library and providing it the key, IV, authentication tag, associated data, and the ciphertext. The recovered plaintext I could then verify to be the same as the original plaintext. I then allowed myself to extract this authenticated decryption with GCM into a small helper function to have the following code investigating the behavior of GCM in case of error scenarios more concise. To investigate the error scenarios, I outlined the 5 error scenarios, which are the use of a wrong key for the decryption, the use of a wrong IV, the use of a wrong authentication tag, the use of wrong associated data, and the use of a wrong ciphertext. To investigate the behavior of GCM in case a wrong key is used, I simply randomly sampled a new random 256-bit AES key and triggered a new decryption, which led to an invalid tag exception, indicating that GCM is indeed capable of detecting the error. I wrapped this into a try except else clause and proceeded to the second error scenario of using a wrong initialization vector. Here I again just randomly sampled a new random IV, and taking the same try except clause as with the wrong key, it was clear that once running this program, also this error scenario was detected by GCM, as the exception path was taken by the try except else clause. As the authentication tag calculated by GCM is 128 bits, I randomly sampled another 128 bits for a new wrong authentication tag, and wrapping this into the same try except else clause and rerunning the program indicated that also this error was detected by GCM. To investigate the use of wrong associated data, I just created a new byte string that is clearly different from the original associated data, and rerunning the program with a new try except else clause indicates that this error is detected by GCM as well. The last error scenario to investigate is the case where the ciphertext is wrong, and to investigate this, I replaced the last byte of the ciphertext with a different byte, and rerunning the program again with this new try except else clause again indicated that this error is detected by GCM as well. This concluded the investigation of GCM, outlining how GCM can be used in Python to provide confidentiality and authenticity to a plaintext, and to additionally bind the ciphertext to associated data that can ultimately be thought of as the context within which the ciphertext is valid.